Assalamu alaikum everyone. So this is our session 10. So in the previous session, as we started our discussion on pandas, so we'll be continuing that discussion. So first I want to address some of the things. Many of you have submitted your assignments. Okay. So regarding the assignments, I want to tell you the first thing I wanted from you is I wanted each of the questions should be a .py file, the solution that you have given. And then you should have zipped that file. That's the first thing I wanted. The second thing I wanted is a IPython notebook. So notebook, because we'll be giving you the feedback on this, and these files will go onto your GitHub. Okay. So this is the first thing that I wanted to talk to you about this. And the second thing that I wanted to tell you is that tomorrow we have a session scheduled at 10 in the morning. So in that, Sanmit Chakravarti, he'll be taking your doubts, and he'll be sort of monitoring what you have done, because we saw many assignments who have directly copied code from different websites. And I also told you that do not use inbuilt functions. Like in some other sessions I told you do not use inbuilt functions, and I have seen that many other people, they have used inbuilt functions. Okay, for example, you have to check if something is palindrome, and some people have used directly sorted or something like this, or some people have directly used indexing. So I wanted to run through the loop. We just admit these people. That's why we wanted to keep this assignment 0, so that you also get to know how to solve these assignments and what are we expecting. So my expectation in the assignments is that you will be solving the problems from scratch. You won't be using any built-in functions. So when the time will be, when we'll be doing some big projects, that time you are allowed to use built-in functions. But for most of your time, you are not allowed to use any built-in function. And second thing is, you are not allowed to copy the code from online repository, because I saw many people have used recursion in some of the questions, and I haven't taught recursion yet, and I'm pretty much sure that if I ask the questions about recursion, the people who have used that won't be able to answer. Okay, so this was for the assignment. So let's now start today's session. Okay, so I think previously we saw how pandas is used to read this data, and then how to create this data frame and create the series and stuff like that. And we had the last part of pandas remaining, that is if we had to combine the data in pandas. So this is, so if you sometimes want to combine data, so giving you the big picture, because we are here dealing with the machine learning, and machine learning basically works on the data. So in order to have the data, we need to read that. So for that, sometimes we have data at different stored at different places, and we want to read them and combine the data. Let me give you an example. For example, if you have the data which is stored in two files, for example file 1 and file 2. Sometimes what you want to combine these data. So in order to do any sort of analysis or do any sort of manipulation on the data, you want to combine the data in certain ways. So for that, pandas provide us various methods by which we can concatenate, we can merge or join the data. So first we will be seeing what I mean by concatenation. Let's suppose I create two data frames. Here I am using the dictionary to create two data frames. The first is data 1 and data 2. These are two data frames. Let's consider these are two data files, data 1 and data 2. So ये हमारे पास दो files है. So now the task is we want to merge sometimes these files. Okay. So what data frame, first initially we'll create two data frames out of these, and then we have a function called as concat. So in concat, what do we do is, so we'll just write this data frame 1 and data frame 2 as a list. So first it will go in the list df1 and df2. So this will go into the list, and then when we print these rows, it will be printed like this, because as you know, this data frame had 1, 2 and 3, 4, and the column names were A and B. So here also similar thing, A, B, but we had 5, 6 and 7, 8. So if you want to combine them like this, you want to combine them on top of each other. Okay, so you have to call this function of concat. Is it clear? I'm getting sound from, I think, Zahid. Can you mute yourself, please? Okay. So this is one method if you want to join these data frames. So what is the real world example? For example, let's suppose you are monitoring the student data. For that you have, let's suppose, class 1 to class 10. class 1 to class 10. So these, you have these 10 data files, so you want to just create one data frame out of that. So for that you will concatenate the data on top of one another like this by using the concat function. Okay, so but this is if you want to merge it like this, if you want to concatenate it like this, like one on top of each other. But sometimes you may want to merge it like this, you may want to merge it horizontally. So for that you have to just change the axis, you have to keep axis 1 over here. If you see, so this concat function, it will take this df1 and df2, and additionally it will take the argument of axis 1. So axis 1 means basically horizontal axis. So ingrain this in mind that when I am talking about axis 1, it means I am doing something horizontally. So if I am doing something vertically, that is axis 0, and by default we have axis 0 argument. So is this clear? So how to use concatenation if you want to merge this data, maybe based on axis 1 or axis 0. So howsoever you want to do that. Then again you can merge the data. So what is the difference between merging and concatenation? So for example, if you have some common column, so here we have some common columns, and you want to sort of merge these based on the common column. Let's do it here. For example, we have two data frames, data frame 1 and data frame 2. So if you see it, how this data will be created, so this is like this. So here we have 1 2 columns. So we have ID column and we have name column. So this is our one data frame. So ID here is 1 2 and 3. So then the name is Alice, Bob and Charlie. Okay, so now we have data frame 2. If you see it, so data frame 2 has same, it has a column of ID and the column of age. So then in ID we have 1 2 and 4, and again 25 30 and 28 are the values that are associated with this. So what if here you can see that the column ID is common in both these data frames. So यहाँ पे हमारे पास क्या है कि दोनों data frames में एक column similar है. So we have ID column over here and we have ID column over here. So based on this, sometimes we want to merge. So what we want to do is, if you match the IDs, then you just want to sometimes append these columns. So it makes sense. For example, if these are the ages corresponding to these IDs, so what we'll do is we'll call a function merge. So here we'll say data frame df1, then df2, then we'll say this on. On basically means what is the common attribute, common column that you want to merge it on. So we are saying it ID. So here you know that only 1 and 2 are common in these. So we'll get a data frame 1 2 Alice Bob 25 30. So because 3 and 4 there is no match, so they will be dropped. Okay, if I go at the coding window to show you clearly how it happens. So let me go to the coding window. Here it is. So let's suppose we have 3 as well here. So let's suppose we have 3 as well. So now whole of the ID got matched. So now what will happen is, now our data frame, when I call this function merge on data frame 1 and data frame 2, and on ID basically means what is the common column that I want to merge them on. So now I have values, 1 is common, 2 is common, 3 is common, 3 is common. So on this ID data column we'll have Alice, Bob and Charlie, and correspondingly we'll have their age. So if I just run this cell, there is some error. PD is no, because I have to again import PD because this has not been run since last session. So let's just import this PD. So now you can see this. So we had 1 2 3 Alice, Bob and Charlie 25 30 and 28. Is this merge function clear? So merge, we are doing it on some particular column, and sometimes you have this data and you want to have a column where they have similar data and you want to merge based on that. So merge is sort of concatenating horizontally. So if you see, you are horizontally concatenated, but you have an ID which is common in both of these data frames. So this is very important for the practical usage. For example, if you talk about distributed computing, so if you have to train a model on a lot of data, so your data will be sort of at different places, and sometimes you want to read files from different computers and want to create a data frame out of that. So then you must know there are functions in pandas like merge, concatenate, which will help you in sort of putting these data together and then training your model. So I'm again reiterating, I'm not here telling you to memorize these functions. You just should know that these functions exist there, and you just need to go to the documentation. You can just write merge pandas and then it will show you the documentation of that thing, and you can, and even merge, this merge will have other attributes as well. So here I am telling you that what is needed. For example, in your projects I'll be giving you some things and you must know that merge does exist. Okay, I think this is clear now. Let's go back. And then there is something called as join. So it combines data frame based on the indexes. So for example, if we have two data frames, let's suppose again the same data frames, we have data frame D, data frame 1 and data frame 2. So the indices here are, so this is A, this is B column, this is A, and this is B, and this is C and D column. Sorry. So here we have values 1, 2, and 3, 4. Here we have 5, 6, and 7, 8. So now you know that the indices are 0 and 1 for this, 0 and 1 for this. Okay, by default, this is a default index. But here we are again creating our custom indices. If you see it here, we are creating custom indices XY and YZ. So it will be like this: XY and YZ. Okay. Then what do you want? You want to join them. Okay, you want to join them, and there is a function called as join. So if you call this join function, there are different attributes. For example, you have to give df1.join, that is, you have to join this with this. Okay, then this is df2, and this is the function you have to call. And then there are some other attributes, some other parameters like l suffix, right suffix, and left suffix, like this. So for this we have this x and y. So x and y is this index. Then we have 1, 2. This is the 1, 2, and 3, 4. This is 3, 4. Then as you know that here we don't have x. Okay, so here it will be not a number, because we don't have, for in this data frame we do not have x. So here it will be not a number because there was no x column in x index in that, so we will be having a not a number. But there was a y column. So for y column we have 5, 7. So 5, 7 will be here. So there is a function join. So main three functions we read about: concat, then we had merge, then we had join. There are a lot of details, we can discuss these things at very length, but I don't want to do that, because you must know that these things exist. Whenever you require them, you just go on the fly for the documentation and you will read it, and you will use them in your own ways. Is this clear? Is this concatenation, is this joining of the data frames clear? Okay, nice. Because what we are thinking is, we'll give you one assignment of NumPy, one assignment in pandas, and they will not be like simply you have to create an array. They'll be sort of story based. So you'll be told a story like, let's suppose you are solving a problem of detecting a medical disease, and for that you have to do this stuff. So you must know what exists there, and you must know how to search the documentation. Then sometimes what you want to group some things. Okay, so there is something grouping in pandas. So what grouping involves is, it involves splitting. So you want to split sometimes some things based on the groups, based on some criteria. For example, if we have a bunch of students here, and if we want to group them based on the scores, for example, we want to have 3 groups in our students. For example, A grade, B, and C. So let's suppose we have 3 sort of groups, because I have a list of, let's suppose, 30-40 students in here. So if I want to group them based on a particular criteria, so I can do that also by using pandas. So let's suppose we'll create a data frame in which we have 2 columns, category and value. So this is the data frame we created. Okay, so now if you call the group by category, dot mean means basically if you want to calculate mean of each category. So as you know that here we have category, there are only 2 categories, either A or B. So we have A, B, A, B, A, B. So if you just create a data frame out of this, you will have like this. You will have a category, okay, then you will have value. So we'll have A, B, A, B, A, B, and corresponding we'll have their values 10, 15, 12, 17, 11, 16. So what I want to do is, because I know that there are only 2 categories here, I want to group the items. So if I do not have this mean, basically, if I let's suppose this mean is not there. So if I want to group these things together, I can just call df.group by using the category, and then we can also calculate mean. Let's do that without the mean first. We'll see what will be the output, and then we can calculate things on that. So here we have this. I want to delete this mean. Okay, so if you see in here, if I want to just group this, because you can see that the data frame got created over here. Okay, so this is the object basically. So now we have the group of these things. So if you want to sometimes calculate maybe mean or maximum of these, so here we had the function mean. So I don't know why it's not working. So here you can see that category A, the value is that 11 is the mean of that, and 16 is the mean of group B. So for example, if you take our example, which we just discussed right now, so in that, if we want to see what is the average marks of people who are having A grade, and what's the average marks of people who are having B grade, and what's the average marks of people who are having C grade. Let's say we have student 1, student 2, something like that, student 30. So each of these people is assigned a group A, B, B, C, or C, something like that, and each of this is assigned a marks as well. We have assigned marks, some marks to them. Let's suppose 10, 11, 12 out of 20, let's suppose. So if we want to see what out of these group A people, what is the average marks of group A people, what is the average marks of group B people, what is the average marks of group 3 people. So here we can use that function group by using the category, and we can call this function mean. Is this okay? Is this clear? Okay. Then you can also do grouping by multiple columns. Okay, you can also apply multiple aggregations, as here we just applied mean, so we can do other things as well. For example, you can group by category, and you can also calculate mean as well as sum. By sum I mean, for example, I want to count all the marks that people have. In this particular case, we have these data frames. I want to first sum up all the values in each category, and then also want to find mean. So there is a function group by, you can call this, and then call aggregate function, and here you can call the value mean and sum. So here you have these columns, like mean of group A is 11, sum of group A is 33, mean of group B is, or category B is 16, and sum of the category B is 48. So this really comes handy, because if you want to analyze some data and you want to sort these functions, like you want to find mean of group A, sum of group A, and sometimes you want to find the standard deviation. All these sort of functions are with this aggregation, and you can use this group by. Then when you have this group data, for example, if you have this group data and you want to apply custom functions, so here we applied mean. We know that mean is defined there in pandas, and you have this function sum. But sometimes you want to apply a custom function. You want to perform a certain manipulation on your own that is not predefined in pandas, probably. For example, which is not so famous. Let's suppose here I want to just find x dot maximum minus x dot min. This is my custom function. Custom function basically means the function which I created, which is not readily available, which is not built in with the package. So what I can do is I can do the similar thing, group by category. Okay, then I'll apply this value and apply this. There is a function apply, and I can do this custom function, because this is the function which I wrote. Okay, so here similar thing will happen. So here this will calculate something x dot max and x dot min. So here you can see that value. So the only takeaway you should get out of this is that we can also call custom functions, not just these functions mean, sum, and things like that, which are pre-built, which are built in the pandas. So you can also create custom functions and apply manipulations on data by using your custom functions. Is this clear? So I have again given some examples. For example, I have created a data frame in here. So this is the data frame I have created. So you know that here we have A, B, C, and D column. So again, I am using group by A, and then I'm calling CD, and I am printing the sum. So basically, I am here telling you that we have these functions group by, while you can categorize and compute different things. Then we have something called as reshaping in pandas. So sometimes, for example, you have an array, you have a 1D array, or you have a 1D, let's suppose, series, and you want to create a 2D data frame out of this, or you want to do some certain specific reshaping. So we also touch this reshaping, I think, in NumPy. So here we have something similar. So we have something called as pivot, so which we'll use to reshape these data frames. Let's suppose we'll create a data frame like this. So this is the data frame, this is our data frame. So in this we have a date column, we have a category column, and we have a value column. So what I want to do is I want to have categories. So here initially I had date was like this, it was printed in the column, and then we have category were like this, and then value were like this. So what I want to do is I want categories should be assigned like this. The column should give the categories, and then we should have a date which should be like this. So there we can say to use this index as date. This pivot is the function that we'll use. This index, use it as date, and then columns. This is the category, and value are the basically the values. This is the value of column. So if you see, this data frame got converted into this data frame. So here we reshaped it basically, because we saw that these dates were repeating. So these dates were repeating. So we can say that, let's suppose this date will keep as an index. Again, these categories were repeating. So we just kept the categories as A and B. So here the big benefit that we are getting out of here is we are reducing it. We are reducing the size, and we are having the same information. So do you agree that this data frame and this data frame contains the same information? Do you agree with this? If you look at these two data frames, so both of these contain the same information, but if you see, there are some redundant information in this. So this will happen in the real world with you. For example, if you are running a shop, and on the similar date you are selling a lot of products, so maybe you have separate entries for all those things. But if you want to do some reshaping and want to remove the redundancy, so in order to remove the space and in order to make analysis simple, you can use this pivot for reshaping. Is this clear? I'm just giving one application, for example, where it can be used. So if there is redundancy in data and I want to convert this data frame into this data frame, so it becomes easy if you use this pivot. Is it clear? Okay, so there is another function, for example, which is called as melt, which also does the similar things. So it takes data like this and converts it into like this, this sort of a reverse what pivot does. Okay, so what we are here, we are defining how to basically reshape. So reshape, we have this melt function, we have the function that we just discussed, pivot function, and then we have the functions like stack, unstack. These are also used for reshaping hierarchy. If you have a multi-index frame, if you remember what is a multi-index frame, so for that reshaping we use the stack and unstack functions. Okay, so I don't want to go into all the details of the functions because it will take me, I think, then more than, let's suppose, 2 months to just cover pandas if I just want to go over each of the function that panda has built, because these all libraries are open source.
Sir, the screen is not visible, sir. It's blurred. Now
Is it visible now?
mm, yes, sir, pretty much.
So what I'm saying is, we do not have time to discuss all the functions, all the functionalities that the pandas provides. Why? Because there are, I think, if not thousands, maybe hundreds of functions that we need to discuss. So for that, I'm just telling you what is pandas capable of doing. So if you want to learn more about these functions, what are the other functionalities, this is the URL where you can go. This pandas.org. So all these resources, they were sort of taken from there, and I took what are like few bits and pieces and tried to compile them so that to give at least overview of what pandas is capable of. And there is a lot of code, and this is just scratching the surface. So I think, and this is enough for you to get started doing any machine learning project which requires pandas, because this is more than enough for that. So whenever you require a function, you will just go to the documentation. So here we'll sort of close this pandas discussion. So was pandas clear? So what is the basic thing that I taught in pandas? It was that clear? Okay. So now we'll go with the discussion of matplotlib. It's a really important library, and it's really interesting and fascinating as well if you see it. So let me just go back and I'll open the matplotlib. So here we have this. Okay. Do you have any questions on pandas? I think you'll be having a lot of questions while you'll be doing your assignments, hands-on experience. That time you'll be using different functions and different things, so that, and the best thing to get better at coding is practice. There is no alternative to practice. So if you want to do anything, you have to practice it. I'm always telling you that it is like swimming. No matter how much I tell you that you have to swim like this, you have to swim like that, at the end of the day you have to go into the water and you have to swim by yourself. Is that clear? Like, you only thing, this practice will make you better. Okay, let's go to this matplotlib. So I'll also switch the coding screen. I'll go to this matplotlib so that it's also visible over here. Okay. Nice. So what is this matplotlib? It again is a library, because we are in the discussion of learning the libraries that are required for machine learning and deep learning. So it basically is used for data visualization. So if you have some data and you want to visualize this, because how humans evolved, humans basically they evolved by seeing a lot of things. So we are really bad at memorizing things. For example, if I tell you that you have to memorize something, so probably you won't be able to memorize all things. Let's suppose you have to memorize that all digits of pi. So it's nearly impossible to remember that. So but what happens if I want you to visualize something, if you come to the room and you see some things in here, then you will remember their names. This is how humans basically evolved. So we get better understanding by using the visualizations. So many of you will agree that, for example, in a lecture, if somebody is just speaking theory, so you'll understand a bit. I won't say you won't understand anything, but if somebody is using some visual things, for example, you are watching a video and you are watching animation and things like that. So how many of you agree that you learn more by watching these animations and stuff like that in like on top of the theory? Huh. So that's how basically humans evolved. So that's why even in the machine learning, so when you have data and you want to understand data, so I told you we are in the phase where we have collected data and we want to understand this data, and we want to see what is the pattern in the data. And we know that out of these tables we cannot make much sense, so we need to visualize the data. So for that, people created the library matplotlib library. So I think it was, I have also included the designer's name. So now it's also open source, the people do contribute to it. So you also can contribute to it if you know, if you get to know this this matplotlib well, so you also can contribute. So these are ever evolving libraries, many of the functions are again added in this, so you can also do that here. It is developed by John D. Hunter. It was developed in 2003. Okay, so what it was inspired from MATLAB basically. So if you know, there is a software, I'll call a programming language called as MATLAB. So MATLAB also uses these plots. So it was used that and to replicate MATLAB's plotting capabilities with Python, because Python was becoming famous, but it did not have a plotting library. So this John D. Hunter thought that I'll create a library matplotlib which will create plots that are in MATLAB. So then he made it open source, and now it has an active group of people which do contribute to it. So how many of you know about contribution in open source? Have you worked in open source? Some of you. Okay. Sometimes we'll also have a discussion on the open source, because I sometimes use to contribute on the open sources, and it's also a really good thing to contribute on open source. Do you know the Linux operating system? It's an open source operating system. So in Linux, there is no authority over there. So what people do is they write their own code and they send their push requests, and if they find some bugs or some things like that, and they get their they do not basically expect a reward. Basically, they are a bunch of uh, developers, and they care for having these softwares as free, and they do not want to license it. So for that, they write some good code, and which is sent to the people monitoring these libraries. That's how people usually go into this open source. So we'll have a separate discussion probably on this open source. What is it? So I hope that you have this is clear that matplotlib basically is a visualization library. So it is used to create visual data visualizations, because it was inspired from MATLAB. So they wanted to have the similar thing with Python. So what is the significance of data visualization? I want to also speak, let's suppose, for some minutes about this. The first thing is this matplotlib. It has versatility and plotting capabilities. For example, you can plot in 2D here. You can also plot in 3D here. It can generate various types of plots that we'll see, right. We'll see it, I think, in the subsequent minutes. So here we have this line plots. We have something called as scatter plots. We have something called as bar charts, histograms, pie charts, 3D plots, and much more. It has a lot of plots. Even you can create animations out of this. How many of you know that there is a guy 3 blue 1 brown, Grant Anderson, I think his name is 3 blue 1 brown. So he's a guy, he creates really good animated videos. So he has written a library. It's some sort of like similar to this matplotlib. So he makes really good animated videos. So you can also create animated videos by using matplotlib. Okay. For example, if you want to create some good designs, so you can also do that. So some people here are interested in web designing. So if you know matplotlib, you can also create beautiful designs, beautiful graphs, and things like that. Then there is another thing: ease of use and integration. So it's really first thing, it's easy to learn because it's in Python. The design philosophy of Python is ease of use. So ease of use basically means, so whatever you have, it will be really easy to use. And then if you are even beginner, so right now we'll be creating some graphs, you'll feel really at home, and you'll feel at ease that we are creating these graphs just by few lines of code. So for example, if you have other libraries like NumPy, Pandas, SciPy, so you can directly use them and seamlessly integrate the code that we write by using the matplotlib with all these libraries. Then if some of like, I hope that some people, they get inspired to take computer science and they go into academia for doing research in computer science. So for that, sometimes you have to plot really good graphs in order to, for example, when you are doing some experiments, and then you have to publish your results. So for that publication quality output, this matplotlib's capability is it's producing high quality publication ready figures that are suitable for academic papers, reports, presentations, and other publications as well. So if you know that, for example, there are research papers are published and there are a lot of diagrams. So most of these diagrams, I say that they are made in matplotlib. If they are related to, for example, coding, and they have to compare these graphs and stuff like that, and they usually make it in matplotlib. Okay, and you can also fine tune them into different formats like PNG. Then you can also create PDFs, SVGs, and stuff like that. Okay, then you have also interactivity and GUI support. So if you know about some things like toolkits, UI toolkits like Tinker, PyQt, and Jupyter notebooks. So Jupyter notebook, you know that there are other UI based things like these. So it also provides interactive features and supports various these graphical user interface like this. So you can create interactive visualizations and things like that. And I'm probably I'll expect you guys at least to try to make some videos by using this matplotlib to for explanatory videos or some things like that. So this is highly extensible, and there's a lot of community support. As I told you, it's open source, so it is being updated. I think like a lot of people they contribute towards this, and it has a lot of community support because most of the people are using it. If you have some problem, so if you search it on YouTube, if you search it on Google, most probably some other people have faced the same problem, and you will be able to get the solution. Okay, so overall, I'll say that Matplotlib's adaptability, ease of use, and customization capability are the and widespread adoption. Like four things that I'll see. The first thing is it's adaptable, and the second thing is ease of. It's really easy to use, and then you can also customize it. And many other people are using it, and these things make it like really important library. That's why people are using it so because of these features. So let's now go into what basically this matplotlib is. So here I haven't told you how to install these things. Today I have included how to install these things also. So I won't go over the details, but I'll be sending you these notes so you can also see how to install these things. I have written a detailed description of how to install these libraries. For if you some people might know that there is a pip, you can just write pip install, for example, the package name. So pip install, you can write, let's suppose pandas. You can install pandas by using this pip command. So there is this pip install, let's suppose numpy, you can install numpy, and then you have matplotlib similar like this. So you can read about this is I think less than one page. You can read it to get at least some sense how to install these things, not just watch videos but just read these and see how to install these things in Jupyter notebooks and Python scripts and other things like that. Okay, let's understand why are these graphs and visualizations important. Why do we use it basically? The first thing is if you want to understand the data. Here what I'm doing is I'm basically trying to motivate you that this matplotlib where will be it used. So if I say that okay, you're going to learn matplotlib just for machine learning library, it's not just for that. You are learning a machine learning library which will help you, so it will help you in other realms of your life as well. The first thing is if you want to understand data and you want to explore the data, so there is something called as EDA. It's called exploratory data analysis. So there are books written on this topic. The huge books are written on this topic, exploratory data analysis, and this is the, I'll say, like among the initial steps that is done in machine learning. So you have to explore this data and analyze this data. That's why it's called explore data analysis. In that you have to understand data and you have to explore that. And if you know how to visualize data, how to create beautiful graphs, and how to create these good bar charts, pie charts, histograms, and you will be easily able to sort of get some patterns out of data by just eyeballing the data. And then sometimes if you have data, if you have to convince somebody of your idea, so the best thing you can do is make pictures rather than text. It's good thing you can make pictures out of this, and you can try to communicate via pictures. That's why it's really useful in communication and storytelling. So why is this point important is because at the end everything works on money. For example, if I create something beautiful but I was not able to communicate properly to the consumer, let's suppose the consumer who wants to use it, so for that you might have seen that people are using beautiful graphs and things like that to story tell these things and then to sell out what they have made. So for that you can use this matplotlib. Then even for the decision making, if you have the good grasp of data, if you understand data well, so it facilitates you to take good decisions. Okay, by having a concise and really good view of the data. So then you can also identify trends and patterns in the data. So if you visualize the data and you can see, okay, this pattern is repeating. If I just make a graph like this, for example, I'll make a graph like this. I'll say year by year I am plotting a data. Let's suppose for the Amazon, let's suppose Amazon is selling something. I am seeing how much is the profit of Amazon, like with each month. So if I make a graph like this, so for example, I'll make a graph like this. So you can see that here, every year there's a peak. So it means there might be some festival over here. So I identified a trend. On this time, Amazon has a lot of customers which buy products from them. So by just eyeballing the thing, by just visualizing out of these graphs, I could extract information that Amazon has really high peak of market, and many people do visit Amazon and they buy products on this season. If you see this, so that's what I mean here by that you can identify these trends and patterns of the data by seeing correlations and by seeing how things are related to each other. Then you can also monitor and evaluate the data by looking at these graphs. You can try to come up with some graphical, because graphical, it really helps in helps understand the data. You can monitor these things, and you can also explain the complex concepts by using these. Then you can also see relationships. So for example, if I give you a graph like this, I'm saying you, so this is the age of people on this side, and then I'll say here is a chocolate consumption. So I can say this graph is somewhat like this. So this dot basically means people. Okay, so you can see that this graph, it rises sort of thing. So we can extract a result from that, that if a person is having a lot of, like for example, he's having age of, let's suppose, greater than 50, so he was actually basically consuming a lot of chocolates here. So we can also create some sense, okay, chocolate consumption, maybe it can cause you to prolong your life or something. Like, I'm just taking a vague example of chocolate. Maybe it can be exercise here. If people exercise, their life is longer, something like this. So if I have data like this, I can easily tell you, I can easily discover relationships between different things like age, chocolate, and age, exercise, and things like that. So that's why sometimes they say that by using for example this product, so we have seen that people live longer by using this. There is a less chance of having heart disease, because they find these what's called as correlations. They find different correlation between different things. So you can also discover relationships. Okay, and then as obvious, I told you that you can also have this enhanced memory retention. If you visualize something, so it will be easy for you to memorize it for longer duration. And I don't need to go over all these things where it helps. So I'll just go over some case studies what have been used, like where this visualization is really important. Why I'm putting so much focus on the visualization, because I want you to learn this matplotlib not just as a tool, but you should think that by using this matplotlib, we can also use it in other realms of our life. It's not just I'll code something for my projects and things like that. I'll code it maybe for my personal use as well. So for there was a pandemic, COVID-19, and we wanted to see how it spread. So we can you can do that analysis. That's called as uh, I don't know how to pronounce this name. So here it is, epidemiological analysis. Some analysis there by which you can see that how the disease spread, basically how this infection was spreading. If for example we had the area on the map like this, and there were some areas over here. So if there was a COVID case detected here and how it spread, so you can have visualization. If you just search on Google or maybe on YouTube visualizations of COVID spreading, they'll show you visualizations. And then for example, if you invest in stock markets, or maybe you do some intraday trading, or you are a good trader, so there you find some that's called as candlestick plots, and they analyze the trends, patterns, and data. They earn money by using this financial data analysis. Then also in climate, so you'll also make graphs in climate, and then visualize these graphs to know, okay, which ice cap is melting, so how are these CO2 levels rising, and things like that. So also this social media analytics, for right now for example we're running this on YouTube. Then there is something called as YouTube analytics, so they show how many new viewers were there, so what was the demography of these viewers. All these things we can do it by visualizing these things. So I have given a lot of examples where it is used, so you can go through these notes and read it for the better understanding where will be used, where will be used. I think I sort of motivated you enough to use matplotlib for your visualizations. Now we'll go to real matplotlib. Okay, so how to basically create this visualization. Now you're, I think, enough motivated to learn about this visualization and how to create beautiful visualizations. So should I go ahead with this matplotlib, how to create the visualizations? Okay. The first thing is, as you know, that we have to import these things. We'll import matplotlib, and we'll import these numpy. We'll use matplotlib.pyplot. There is a sub module called as pyplot. So we'll import this as plt, and we'll import numpy as np. Okay. So I want to make you understand that there is a structure. For example, whenever you create something in matplotlib, there is a hierarchical structure in that. So it consists of three things. One is called figure, then another is called axis, and then there are called something called as subplots. Okay, they basically collectively form the basis for creating organizing plots. So basically we'll be creating plots, different plots. So here we'll be having main three things. Just remember these three things. The first thing that we'll be having is figures, then axis, then these subplots. Now we'll go in depth what is each of them, and then we'll make some plots. What is this figure? This figure is basically a top level container. Whatever contains everything in matplotlib, that's called a figure. Okay, it may be a window like this, okay, and there will be something will be drawn on this. This is called a figure, okay. If you, for example, write something, so if you are painting something there.
ये जो blur है
Hmm?
screen blur है
Is it good now? Because I cannot
no
do
sir
much in this. Sometimes, like this mobile data connection, they are really unstable. So what I'm saying is, for example, if some of you paint something, so they have a canvas. तुम्हारे पास कैनवस होता है कुछ पेंट करने के लिए. फॉर एग्जाम्पल यू वांट टू क्रिएट अ ब्यूटीफुल पेंटिंग, तो तुम्हारे पास एक कैनवस होता है ऑन विच यू पेंट. So this canvas is sort of this figure. In matplotlib we call this canvas a figure. So that's why I've written here. It acts as a canvas where all the elements of plot, for example labels, and we'll discuss the what are these things. Basically whatever we want to plot, this goes under this figure. So figure is top level container and it acts like a canvas. Remember these two things. So how to create this canvas? Okay, so let me show you how to create this canvas, how to create this figure in the coding window, so that you get a better hang of this. Okay, is my coding window visible? Is it visible now? Wait. There is some problem. Let me fix it. So how many devices are connected? Wait, let me just disconnect this as well. Is it visible now? Because I just connected one device to this. First thing is I'm getting a lot of calls on this. Just tell me whenever it is good. Just tell me there. Should I even reconnect the net? I should reconnect. I suppose. Let's just reconnect it. Is it good? Hello, am I audible now? And is the screen visible? Because I sort of reconnected it. Oh, there is a serious issue then. Wait. I am on the 5G internet. Still, it is having certain problems. I don't know how to fix it. Is it visible now? Okay, let me just do a speed test. I'll see if the speed is good. I think the speed is good. I don't know. Okay, again, just like for the sake of other people, I'll just do a speed test. I'll see if the speed is good. I think speed is good now. So my perfect. Should I go forward now? Okay. Okay, maybe there was a temporary disruption. Sorry for this. So what I was talking to you about is that there are three parts to any figure that you are creating. The first thing is figures, then there is an axis, then there are subplots. So I wanted to tell you what is the meaning of this figure. So first thing is figure. So I told you this figure is a top level container in matplotlib. So it is like a canvas. If you want to paint something, if you want to paint a picture, so you have a canvas to paint picture on. So that's what this figure is. So let me show you how to create this canvas first. So we'll import this, import matplotlib.pyplot as plt. Then what we'll see is we'll say fig figure plt.figure, and then we'll say make a canvas. So if you just run this cell, you can clear there is a canvas like thing over here. Is this visible on the screen, the canvas? It's just empty. There is nothing on the screen, just a box. So this is what canvas means. So this is what a figure means. So here you will be putting all the things, all the details, all the paintings, all the visualizations that you want. Okay, this is called a canvas. Then we have something that is called as axis. Okay, they are the actual plots that you will that you want to plot. So here we will visualize it. So they are the actual plots that you will plot. For example, this is a figure, and in here you want to plot something. So you want to plot something like this. Okay, so this is what I mean by axis. So there can be multiple these things. This is called one axis. Then we have, for example, other axis, some things like that. So here we create that by using this figure is by using created by plt.figure. So now you have a canvas like this. So now if you want to create an axis, a plot of this, so you will just write fig fig add subplots. Okay, so here one basically means create one row, create one column, and this is the first subplot. So we'll also change this thing. We'll see that in action. So first remember that we have a canvas, we have a figure. So out of this we have some axis which we have a plot on which we want to create something. So going back to the coding window, if I show you, if I run this cell, for example, so this is the axis. So here you can see that we had a figure. So in that figure now we had 1 2 3 and 4 axes. Okay, is this clear? Because here I created 2 rows and 2 columns. So if I can create like this. So on this figure, so I can create 2 rows and maybe 3 plots. Okay, so now you have this. So now you have 1 2 3 4 5 and 6 plots, things like that. So these are called axes. So that's why I have created axis and figure. plt.subplots is the function. It returns two things. It returns a figure and it returns axis. Axis basically means these 1 2 3 4 5 6. So how many axes are in this plot? So there are 6 axes. So figure is a top layer container which contains all of these things. That's called a figure. Then we have something called as subplots. This basically is a grid of multiple axes. So for example, we had these plots like this. If you remember the figure, we had a figure like this. Out of this figure we had, this is called a plot, this is a plot, this is a plot, these are plots. Together these plots are called as subplots. Okay, so grid of multiple axes for example within a single figure is called a subplot. So all of these things will be called as subplots. Together when they are called subplots, one thing is called a plot, or one thing is called plot is also called as axis. This is outer thing is called as figure or canvas. Technically they are called a figure, axis and subplots. So you can just remember like this. We have a canvas, and on the canvas we'll plot something, and we'll have multiple plots, or they are called subplots. Okay, so what these subplots do is they allow us to organize these multiple axes. Okay, because right now I showed you that I created 2 cross 3. That means we had 3 plots, and we had in total we had 6 plots, but they were arranged in this fashion: top 3 and bottom 3 plots. So these together are combined called as subplots. Is the concept of figure, axis and plots clear? Is it clear? Okay,
Yes, sir.
so now we'll be creating something, we'll be writing some things on this. So that's why I showed you, like, if you want to create some plot, so you can create it like this. If you want to create subplots, you can create it like this. And now we want to plot something on the axis. Let's go back to the window, and we want to plot a simple thing. So as you know that each graph basically has two axes, x-axis and y-axis. It's not axis, it is axis, this axis. Okay, so if I write anything, so here I have an x-axis and I have an y-axis. If I draw anything on a two-dimensional plane, so in order to draw anything, so I need a data point. I need some recordings over this x-axis and y-axis. Let's go with an example. For example, let's suppose we have an example of cricket match, because most of you people will be watching cricket match. So in that, let's suppose we have runs. Okay, then we'll be having overs over here. So how many overs were played? So let's suppose in the first over we had 6 runs. Then in the next over we had, let's suppose, 10 runs. This graph will be something like this. So we'll be having a graph like this, something like this. So here we say that till the 50th over, let's suppose the runs were 300. Okay, so we are plotting these things on the this is called as x-axis, This is called x-axis and this is called a y-axis. Okay, so this is our graph. This is how a typical graph looks like. So we have two axes. So I am talking about 2D graphs. So we have 3D graphs as well. So we have two axes in x-axis we are saying how many runs were scored, and in the y-axis we have how many overs were played. So for example, in the first over we saw that 0th over the score was 0. Okay, then the first over, let's suppose 6 runs were consumed, then something like 12 runs, something like that, and at the end of the 50 overs some 300 runs were scored by the team. So is the concept of this graph clear? So we have an x-axis, we have a y-axis, and then we have some data. So if I just consider one, if I for example drop a point in here, so this point basically represents, I'll just draw a perpendicular over here, and then I'll draw a perpendicular over here. So this data point tells me if we have, for let's suppose this is 20th over. So this data point represents 20th over, and this line, this intercept here represents how much score was scored till 20th over. Let's suppose it was 120 or something like that. So we have these bunch of data points in here. So is this data point clear? If I just draw a point, what is the representation of the point? So on the x-axis we basically had runs, and on the y-axis we had overs. So if I have been given one data point, I'll just drop these perpendiculars. I'll drop perpendicular from that point on the x-axis to know the number of overs, and if I want to see how many runs were consumed till that over, I'll just draw a perpendicular on the y-axis. Is this clear? Then only we can go ahead and plot some things. So now you know that in any 2D plane, in any 2D graph, we need two things at least to have a point. For example, in terms of this cricket, we needed number of overs and number of runs. So there were two things that we need to think of. So that's what we'll be doing here. So I'll create a simple graph in the coding window and you will see that. Let's suppose in x-axis I'll create a list. I'll just plot my own graph and then I'll see how to create the sine graphs. So let's suppose in the x points I have some points in which I'll have points 1, 2, 3, 4, something like this. Then I have one y, and in which I have squares of these points. Or let's suppose I'll have 1 square is 1, 2 square is 4, then we have 9, then we have 16. Is my screen visible? I'm hoping the screen is visible. Okay. So now if I want to plot it, the first thing is I'll create this figure and these axes. So one simple thing is, so I'll write this fig figure and axis plot dot subplots. Okay, by default it will just create one figure. Okay, so what will happen is now I will create on axis dot on that axis I want to plot. What I want to plot is this x and y. Okay, and I'll write plot dot show. Maybe it will just run like this. So do you see a graph over here on the screen? Do you see a graph? Okay, so I hope that this graph is visible on the screen now. So I had these x points and corresponding I have y points. So what I did is first I created a figure in which I created only one plot. So in that plot I wrote ax dot plot and gave the arguments as this x and y. So here you can see that a line was drawn in that. Now let's create a little bit complex graph. How many of you remember what is this linspace doing? That's why I told you remember numpy. How many of you know this? What is this linspace doing? Zubair? Is Zubair there? Sharika? Am I audible at least? So what is this linspace doing? Do you remember what this linspace does? I told you, like, if you want, it basically creates some points, right? So okay, so what it does is, so we have this np linspace, so it will start with 0 and it will go till 2 pi. Okay, and it will create 100 points, equally spaced 100 points. So this is our x-axis. So what we want to do is, again, so we have these x points and we want to know the values of these. For example, हम लोग को sine function plot करना है, sine of 0, sine of 1, sine of 2 degree, sine of 3 degree. I want to see how the sine behaves. Okay, so this x basically is the points at which we want to compute the sine function. This y are the values. if I just plot this thing, if I just do one thing, I'll comment these things out and I'll print this x and y. So I want to show you the values basically first. So there are values present in this x and y. Okay, so here if I, so you can see that there are 100 values in x, there are 100 values in y. Okay, so I have first created this linspace, then I have applied sine function on this x values. Okay, so now I want to plot this. Now I know that this is the sine function. So here what I am doing is this line, this figure.ax, you know that it will just create a figure, and at that it will create one plot. So now I'll say ax.plot. So what will it do is this ax.plot will basically plot the thing if you see it. So now are you able to see the plot? So this is like a sine wave. So you might have heard sine wave. So this is the behavior of sine wave. Is it visible on the screen? So is Rian active? So are you able to see the sine wave on the screen? Okay. So now what I want to do is I want to set a title for this. Title basically means I want to show you that this is a sine wave. So for that we have a function called as set title. So I'll just comment it out. I'll say ax.setTitle and I'll name it as sine wave. So if I just again run this cell, so now here you see the label sine wave. Okay. Now I also want to see that there is this x-axis and y-axis. I want to know that these are the, this is x-axis and these are values corresponding. So I'll write for example x-axis and y-axis. So there are functions set x label and there's another function set y label. So if I now run all of the code, so you can see that we printed a graph and then we saw x-axis as well as y-axis. Is this clear how we create a basic graph of sine wave? Maybe we can do it a similar thing for cos. So if I just write a cos over here, this graph will sort of get flipped. This is how cos behaves. Okay, on these points which we have over here. Okay, we'll go back to the sine. Okay, so you just saw there is some title and there are some x-axis, y-axis, and then you can also customize this. For example, right now what we did is we just created one plot. What we did is we created one plot. Now I want to create subplots. So what I want to do is I want to create two graphs. So I want to create two plots. So here I have given this argument as n rows is equal to n columns is equal to 1. Okay, so what will happen, this will basically create two graphs, one on the top and another on the bottom. So now what I have is I again am using this linspace to create some numbers between 0 to 10 and they're equally spaced. I want to create 100 numbers. So y1 basically says this is the sine function and y2 computes the cos function of these x values. So on the first plot, because I know that I have created two plots, just going back to the screen. So what I'm saying is in here, when I run this cell, so what will happen is a figure will get created. Out of that figure, I'll have one axis on the top and then I'll have one axis at the bottom. That's what this means, two rows and one columns. Is this line clear? What it does, what this line does? Is it clear? So then I am creating x value. So I am having a numpy array in which I have 100 values ranging from 0 to 10. Then I have y1. y1 basically is sine of this x, sine of all these values. And then I have y2. y2 basically is cos of all these values. So I have three values. So now I want to plot, let's suppose sine wave on this top plot, and on the bottom I want to sort of make this cos wave. So in order to select this one, because we know that we have a figure, we have this axis. So what we'll do is we'll say axis of 0. Axis of 0 will select this. So there are indices as this. This is 0 index and this is 1 index. So x of 0 means I am selecting this one. Then I am saying plot. So I am plotting. And then I am saying x. So this is the x-axis. Something will get printed on x-axis. Then I have y1. So basically I am printing sine. Then let's just remember this. We are doing some customization. For example, I want a dotted line which is red color. R means red basically. And then I put a axis dot set title. I am setting title for that as sine wave. Okay. Then again I am doing axis of 1. Now I am selecting this plot, this axis. So I am saying axis of 1 dot plot and x and y2, and giving it a green color and some dotted. And we'll also look at what these things mean. G and these R. Then I am setting a title of cos wave for the second. Let's suppose it's called a second axis actually. And then I'm also setting a label for this. That's time. Okay, in order to adjust these plots so that they fit in the figure, they fit in this canvas properly, so I'm just calling a function plt.tightLayout. So now if I run this function, we'll see that there will be two graphs. On the first we'll be having a sine wave, on the second graph we'll be having a cos wave. But as I told you that we have a figure outside, we have these axes, and together they are called as subplots. If I go back to the screen and if I run this, now you will see a sine wave is there, then you will see a cos wave is there. Is it clear? How I created two graphs on top of each other. And now you can see that this is what is meaning of this. If I remove these arguments, I don't want you to confuse with these arguments. I just remove these because they are just there for coloring, labeling, and stuff like that. So now you see two similar looking color, and they are, one is sine wave and this cos wave. So here if I again put those, this basically means it should be a green line, and this is the symbol dot and this. So here it should be a red line, it should be a dotted red line. So that's why here we have a dotted red line, and then we have a line like which looks like this and has a color green. Is this clear how we created these two graphs? Nice. Let me go back and okay, these are the sine and cos waves. Like, let's first see what are the different portions in the figure, so that if I tell you this is the title, this is whatever it is, so I'll tell you what are the parts in the figure. So you now know that there are three main important things. The first thing is there is a figure, then there is a axis, then there are the subplots. So what this thing is called, if anything is written on the top, that's called as title. Okay, in our graph which we previously printed, sine and cos waves that we printed were the title. Is the title clear? What is title? Title basically whatever we write in the top is the title of the graph. Okay, then we have what is called as markers. For example, if you have some things like this, things like for example data points like this, these are called markers. So we'll see how these markers are used. Okay, and then we have, for example, if you have on a figure you have these are called legends or legend. So you are saying that this blue is a blue signal, and this is probably, for example, an orange signal. So if you want to highlight this, what is blue and what does blue signify, what does this orange signify, we put what are called legend. Okay, then we have a grid. So you saw these dotted lines over here, horizontal and vertical dotted lines, we call this a grid. Okay, then we have this, if you see, we have this x-axis and then we have this y-axis, and then this is called a label. So if you put anything at the bottom of the graph, this is called a label. For example, x label, and you want to put any label on the y-axis, you call that a y label. We have x-axis, corresponding to that we have x label, and we are corresponding to y-axis we have y label. We have title, we have something called as legends, we have a grid, we have this y label, we have this x label, we have markers, then we have what is called as tick labels. So if you see a graph, so sometimes in graph we mark something like this. So these things are called tick labels, these things. Okay, while you were making graphs, when you were probably in your 9th class or 10th class, you were making these marks. These marks are called ticks. So there are minor ticks and major ticks. For example, if you have a grid like this, so you have a graph. So this is a graph, and then you have grid. You have a grid like this. So whatever comes on this is called a major tick. Then in between there are small ticks. They are called as minor ticks. Even if you have that scale with you, if you know that there was a scale and that used to have, for example, 1 inch, there was a big mark. This is called as major mark, major tick. Then in between there were smaller marks. Do you remember the scale? How many of you remember these things? Okay, so there were some major marks and some minor marks. I want to put the terminology straight, so that if I tell you, okay, I am putting a legend, you know what legend means. I am putting a grid, you know what grid means. So now we saw what's the title of the figure, what is the meaning of this minor tick, what is the meaning of this major tick label, and what is the meaning of this label, x label, y label, what is the meaning of this legend, what is the meaning of this grid, and then whatever this, for example, if I'm plotting this blue line, these are called lines, simple lines, and these are called markers. Whatever we can put a marker over here. Is the concept of these figures clear for whatever goes into a plot? Is it clear? I hope that this is clear now. So if I talk about, for example, let's put a grid on this, I think you won't get confused. By grid, I mean that I'll put some horizontal vertical lines. Okay, so that's what I have written here. Figure, a top level container, axis, whatever represents the individual plot. So there is ax as axis. So axis basically here means, so there is an x axis and a y axis. So title is a text element that provides a title for the entire plot. So there will be a title written on the top over here. So this is the title. This is our title. So this is our axis, x axis, y axis. So then we have something called as label. So we have some label for, if I write x axis, some, let's suppose words, let's suppose score. So this is x axis label, this is y axis label, that's label. So there's a box called as legends. So legends by me, for example, if I have multiple things going on in this graph. So if I want to show that this black represents, let's suppose, uh, Pakistan's run curve, and this represents India's run curve. So these things which represents, so I want to put it green. So green thing here represents India and black thing represents Pakistan. This is called legend. Then we have these tick and tick labels. So I told you what ticks means. Ticks mean these small marks which are on the axis indicating the specific data input basically. So whatever we have the label correspond that tick, we call that as tick label. Okay. Then we have these lines connecting. They are called as spines. So and grid, you also know that I also showed the grid. So is this clear? Is this much clear? Like we just talked about what are the different parts in a plot basically.
सर स्पाइन रिपीट करना.
I haven't told you spines, so you can just read over here. So they are the basically lines which connect these tick marks. So you can just go on the graph. So here I have mentioned spines somewhere also. So if I have these tick marks, so where are these? So if I connect by this, so this basically I can call it a spine. So these things, for example, these tick marks are being connected by this. So for example, not exactly this. So here, if I make a graph, separate graph like this, so it's a figure like this. So I had a graph like this. So if I have tick marks over here and I have tick marks over here, so here if I want to put these things so as to make the graph parallel, because sometimes we want to plot some things on over. So these things are called spines. So these things are called spines, which are not on the x and y axis but are parallel to those. So if you see on the figure, so I have written it somewhere here. So you can see that here is called a spine. So this graph basically. So you can just read it. I don't want to memorize the names. You just can read out these notes and you can say what is the meaning of label, what is a legend, and then what is the tick marks, labels, spines. That's why I've written this. Lines connecting the x ticks marks and noting boundaries of the data basically. So if you have the data and data is like this. So now you know that here we are finishing this. So we'll put a line over here because now the graph is finishing. So here we'll call a spine. So if our graph extends like this, so we'll put a mark over here. We'll call it a spine. Is it clear? Okay. So we saw some simple examples. We saw how to create this graph, and we saw the labels as well, how to put a label on this. So this is the y label, and this is, for example, if we have this plot, we want to plot 1, 2, 3, 4. So here we put some numbers. So y label will happen as y label will appear as some numbers. Then we want to show this graph. So graph will look like this. This is a simple graph. So now if I have a graph like this, which I just printed on the screen. So we had 1 is 1, 2, 3, 4. Then we had 1, 4, 9, 6. Basically squares of these numbers. So we can just plot a graph like this. This is the simple plot of the graph. Now you want to format this graph. So now you basically know how to plot a graph. If I have an x-axis value, if I have a y-axis value, I can plot something. So you want to format that. You want to change the color maybe. You want to change the line style. You want to adjust the axes and these labels. You want to change the plot appearance. So there are things like that for the graph. So we just saw that we printed, when we are printing the sine and cos axis, we printed something red and something as green. Okay, we printed something as red and something as green. So for that we use abbreviations. B for blue, R for is red, and then we do G for is green. They're for the color names in order to define the line colors. And in order to modify the style, sometimes you want to put a straight line like this. Sometimes you want to put a dashed line like this. Sometimes you want to put like some other sort of line. Let's suppose one dash and then a lot of blanks like this. So for that you have these dashing styles. If they are visible on the screen, I'll just zoom it in so that it is visible. So these are the marks which you can use. Okay. Then we have markers as well. For example, you can put like this graphs like this, or like something like this. You have, for that you use these symbols, so that there are different lines. For example, if you are plotting things on the similar graph, so you want one graph to be straight, one graph to be solid lines, one graph to be dashed line, and some graph to be some other lines, and for that you can style these things by using these symbols. Okay, let's go and check it on the coding window to see if I can change these things and do some things with the lines. Hopefully the screen is visible. I'll just go over there. The first thing is I read it as red, and then if I can play green, I'll just print G and O. You can see that here we printed some green dots. You know that there is some data, and there is some x corresponding values and y corresponding values, and we want to print it as green, then as O format. O basically means have these things as circular. So if I want to print in some other x, for example, there is some symbol like this as well. So if I print it like this, now you see that the triangles got printed. That's why I call these markers. These are markers. This is a triangle marker. So now do you understand what marker means? Marker basically means a data point. So if I want to print something else, so I can just print S. So you can see that now this S means square. So square got printed. Now we printed triangle, we printed O, like circular thing. So there are different things like that. Now if I want to also change the line of this, so now I saw that how to change these markers. So you can, if I have 2-3 things plotting, for example, I have this, I want to plot one thing as, let's suppose red. Here is I red, and it should be dashed line. So I am writing R and dash dash. Okay. Then what I am writing is BS. So these are basically blue, and then write this S means square shapes. Then I am writing G and this exponentiation G. This basically means green color, and this means a triangle. Okay, is this clear? So here we printed 3 lines. So first we printed R double dash, that's red, a dashed line. Then BS means blue line with a square thing. Then we printed G, a green line with this triangle. So if I run this, we can clearly see that this is the graph that was printed on the screen. It's visible on the screen? Okay. So now we know how to create a graph, and now we are trying to customize the graph. कि graph को customize कैसे करना है, how to make it colorful. So you also might watch cricket match. In there you see that they have these 2 things. For example, one has Indian team run, and then other graph is for the Pakistan team run, and then you see these different colored lines and things like that. They customize these things based by using these sort of things. Probably it might not be matplotlib, but they have a library written for that. Okay. So you can customize all those things. So I have again going back to my tab screen. Okay. So here you can see that you can also customize, adjust these axes and labels. You can change the plot appearance. So I just showed you how to change these line styles and colors, things like this. So now we'll go to. So we'll go if we have, for example, some keyword string. So if I have a dictionary, so and I want to plot that. So what I can do is, this is a dictionary data. So I have created A, and I have created some numbers in there. Then we have C, then I have created some other numbers. So I think I have made it clear what is the function of this np range, npa range, np random rand.int, np random rand, and so I have covered this in numpy array. That's why I have order in teaching. The first thing is we covered this numpy. That was the first thing, because we're heavily using the numpy right here. So then we covered this pandas. Then we covered this matplotlib. Because if I have covered like in some other order, probably there will be problems. You won't be able to understand these things. Now what I'm saying is that, so I have a dictionary of these values. So A has some certain values, C has some certain values, D has some certain values, and then I have data of B. So I am putting some data of A plus and doing some computation over here. I am data of D, doing some NP absolute. Basically I am creating some data. This is creation of data. I hope that you will be easily able to figure out what this means. So now what I'll do is I'll create some other plot. This is called a scatter plot. Okay. So what I'm saying is I'm creating this A, B, and then writing C is equal to C, S equal to D, and data is equal to data. So what will happen is, so this thing will get created. So this basically is some data, and these are the data points. So we'll see what a scatter plot is. I just want to show you that we can also plot the things by using these keyword strings. Okay. If we have this was our dictionary, then we added some more data in there. So we can have these strings like A, B, and then we'll put these arguments in the scatter plot. Then this X label basically means this entry A, this Y label means this entry B, things like this. Then we can also plot by using the categorical variables. So if we have categorical variables, because I'm saying if sometimes we have keyword strings, we can also plot. Categorical variables mean this basically the type of data that we have. Categorical variables, we have group A and group B, group C, and correspond their values 1, 10, and 11. So we have graphs like this is called an bar graph. So I'll explain all of these things. I just want you to show a glimpse of all of these, then we'll explain this in detail. Okay, so I'm plotting a bar over here. Then we can also plot some points like this. We can also plot like this is called a line graph. Okay, so if we have categorical things, by categorical I mean there are different categories. If you can see here, we have group A, group B, and group C, and there are corresponding values. So in this, if you saw here, we had these keyworded strings. So in here we had categorical variables. Okay, we also can print this. Now we also can control the line size, line style, line width, line color that we saw, and even the transparency, and in the marker style that we previously saw. So here again, going back to this sign, I think this is the sign graph again. So here I want to put line style dash 2 dashes, so you can create 2 dashes like this. So label can be dashed line. So here is this is the label. This here means the label. So I'll just run it to show you the label. This is just giving you a glimpse of the thing, so that when we'll be doing our projects, you know what is coming basically. So here if you can see it, so if I do not put this, line style, so you know that what will happen, it will print a solid line. It will just print a solid line. So you see this is a solid line. So but if I want a dotted line, so what I'll say line style, even if I can remove this line style is equal to, so it will still print this dotted line. So I want a dotted line. So if you can see, this label is dashed line. So label basically is here. The label basically means legend. So this is our legend. So we have this x-axis, y-axis, and the line, and we have title as line style dashed. So again, you can also print this thick line. For example, you want to thicken this line. So you can write this line width argument. So here I have given 2.5. I can write 3 here over. So you'll see a more thicker line will be there. So you can see this line got thicker. So if I by default there is some value. So if I want to thin it a bit, so I can just write 1. So you can see that the line became thinner. So you have control over this line width as well. So now if I also want to color it, so there is an argument color which I previously showed. You can just write G, or you can write green as well. So I'll just print it, and you can see that line color is green. Okay. Then there is something called as opacity or transparency. By that I mean how much should this graph be visible. For example, so here we have this alpha. So if I put alpha is equal to 1, it will be fully visible. Sorry. So if I put alpha is equal to 1, you can see that this is fully visible. So, but if I want to make it a little bit transparent, so the value can take from 0 to 1. So I'll write 0.2. So you can see that it will lose some transparency. So it became a little bit transparent. So that's what this alpha does. So there are a lot of arguments. I just want to see there are arguments that if you want to print a transparent graph, you just have to write how to print a transparent graph, and you will find this. There are arguments of alpha, and this is called transparency or opacity, and you can control this value. 1 basically means fully opaque, and 0 here means full transparent. So there is no graph now. So 1 basically means full opaque. So the value ranges from 0 to 1. Is this clear? Is the concept of transparency clear? How to control the width, how to control these colors, how to control these markers. Even this is the marker as well. So if I want to put these markers, I create a marker size equal 8, and by default this marker size will be something. If I want to make these points a little bit bigger, I can put for example 10. You can see that you saw that there are bigger points on this. So how many of you at least have experience with the graphs? Maybe you have watched cricket match and they show a lot of graphs in there. That's how they create these graphs. Maybe they don't use matplotlib, they use some other libraries, but that's how they create these graphs, by using this. So here you can also see the labels in here. I think line width is clear to you, that I want to increase the decrease the line width. Okay. We also went on creating multiple graphs. So we can also do that by using, for example, if you want to create separate figures, so you can just write plt.figure. It will just give you a one figure, plt.figure. So in before we saw that there is a function called plt.subplots. So it was giving a figure, in that it was giving some subplots. So if you see in here, so we are just creating one figure. Let's suppose this is not there. This much code is not there. Let's comment it out. So in here, if you see, I'm just creating some figure. So it's basically, I'm repeating that cos and sine. So because I explained that cos and sine, so I hope this is now understandable to you. So here I just created one figure. If I want to create another figure, I can repeat this code. I can repeat the same code here again. if you see that this is the repetition of the previous code, but just giving the different values. For example, x1 is here, so I'm giving x2 over here. So x1 and x2, here is here is x1 and y1, here is x2 and y2. So and I'm also changing these colors, and I'm also changing this label. So this is another way of creating different graphs. So before that we saw one thing that you can create plot dot subplots. Plt dot subplots was a function which basically it gave us a figure as a return and an axis. So by that I meant it gave a figure and an axis in this. So you also can, without using these subplots, you can just go and you can print these things by just calling this plot plot. If you see this, this is another way of creating two graphs. If I now run this, and you can see there are two graphs on top of each other. But I think that one is much better because subplots gives us more control. So they are in the similar figure, and they have same canvas, and you have a lot of control over that. What's the time? Still there is some time left. So and the thing is, you can create subplots in multiple figures. So subplots in multiple figures is like this. For example, if you have a figure 1 and you want to create two axes in that, and then you have a figure 2, you will create something else in that. So if I want to show you in here, so by this I mean you want to create a figure 1, in that you want to have two graphs. For example, this is some figure, and in another figure you want to have one graph. So you can also do that. Okay, so here we have created that by the code. Just see this code, I'll just reiterate, and here you have now called this function subplots. In the first figure, what I am doing is I am just calling plt.figure. This will create a new figure. This will create one new figure. Now what I am saying is I am saying plt.subplots 211. It says there are two rows and there is one column, and then we have one subplot in that. Then I am plotting plt plot x y1 g, and then for the same figure this much code. If you see till these lines, so we are selecting one figure, and in the one figure we have these two subplots. So how to select these subplots? This 2 1 1 basically means we have a plot in which we have two plots and we have one row, and I am selecting the first figure. So it will be easy to explain maybe on the tab. So what I am saying is, so this is figure 1, this is our figure 1, this is our figure 2. Okay, let me select this and bring it where the code basically is. It's really important how you print these things so that you get a good hang of these things and know how to plot these things together. So here it is. So what I'm saying is, so plt.figure, what it does is this line plt.figure, it basically creates this one figure 1. Okay, then we have plt.subplots 211. So what it does is it has the control of this, because 211 means because there are 2 1 and 2, and 1 basically means 2 1 comma 1, select the first one. So there are two rows, there is a one column, and I am selecting subplot 1. Is this clear? Are you with me till now? I am saying that you are creating figure first, in that you have two axes, and what I am saying here is subplot 211 means that here we have these two subplots, and then we have one column, we have just one column, and we call it one subplot. This is one subplot. Then I'm plotting something x y1 g label. So anything that I'll plot here, it'll get plotted on this. Okay, then I'm putting a title of this, I'm putting legend, everything I am controlling basically this one. Now if I want to do something on this, so what I'll write is I'll say 2 1 and 2. Just remember, see the syntax. So if you see it over here, so here it was 2 1 and 1, 2 1 1, because we were working with the first figure. So here it is 2 1 2. 2 1 2 basically means now you are in this figure, you will be working with this figure. So whatever you are plotting now, so you are plotting x y2. So I know that this is sine, this is cos, and there is tan. Y1 is sine, y2 is cos, and y3 is tan. So if I am printing anything in this code chunk, so it will get printed onto this. If you see it, it will get printed on this. So now figure 1 is finished. Till here I was having figure 1 till this line of code. So I am again calling this plt.figure. What will happen is it will again print another figure. So this is another figure. So for that I am now creating only one plot, so I don't need to call subplots. So is the difference between plot and subplots clear? By just calling plot, I'll create one plot. So here I have created one plot. Here I have just created plt.plot. So, but if I want to select a subplot, I have to explicitly call this subplot function first. Then I can plot on that. It is like first taking a canvas. Let me give you an example. अगर तुम में से कोई painting करना चाहता है, for example, he has two canvas now. He has one canvas. He has two canvas. In the first canvas, he wants to make two diagrams, or he wants to make two paintings on one canvas. So, in order to make two paintings, he must call this subplot function. क्योंकि मेरे पास एक कैनवस ऐसा था, दूसरा कैनवस ऐसा था. So in the canvas, first I wanted to create two figures. I wanted to create basically some two things, 1 and 2, something like this. So on the second canvas, on the second figure, I just wanted to create only one thing. So in order to do this, in order to have this control, the first thing that we learned was you can have a separate figure that we saw in the previous session. You can just put this plt and plot. But if you want to print this on similar canvas, so what you can do is you can call this subplot, and you can say there are two figures and it has one row, and I am selecting the first one. So this again say the same thing. We have two figures, it has one row, basically it has two rows, it has one column, then I am selecting the figure second, I am selecting the plot second, then I am plotting something new. Is this clear how you can use multiple axes and how you can do all the stuff, and you can create multiple figure within the figure, you can create different plots? Is this clear? So you can see that this figure 1, it has two curves. It has a sine curve and it has a cosine curve. So in the here you have a tangent curve on figure 2. Figure 2 only has tangent curve. There is no subplot. No subplot. So here we have 2, 1 subplots. So because in the rows we have 2 plots and it has 1. Let me again test you. I want to see if you have a better understanding of this. What if I write, instead of this 2, 2, I'll write 2, 2. And here I'll again write 2, 2. So now how many plots can I plot in the first figure? So how many basically these different plots will be there?
Figure coding window is not visible to us.
So I'm saying I changed here, if it is visible now, I am changing here 2 and 2. Initially it was 2 and 1. So by 2 and 1 I meant that there were 2 diagrams, only 1 column. So if I have this now, so what should get printed on the screen? Nice. So how many rows and columns will be there? There will be 2 columns and 2 rows. Okay, and this 1, 2 basically means you are selecting those columns. If I just run it, you see this. I am selecting the first and second. So I can again create one more plot. So let's suppose I'll just create subplot 3 over here. I'll copy this code, I'll paste it over here, and I'll just write, let's suppose 3 over here. Okay, I'll create the same thing. So do you now see the third figure also got created in the figure 1? The third plot basically got created. At max, I can create 4 plots. I can again print something similar. Let's suppose I'll give it some green color and I'll print this 4. So in one figure you saw that I created 4 plots. So what will happen if I write 5 over here? This basically should be an error. So you saw that it is an error. Because we have access to only how many figures? 4 figures. But I accidentally pressed, let's suppose 5. So I cannot access this 5th figure. Is this concept of these figures and how to create subplots by using this without calling the axis? I also showed you one method while you have axis of 0, axis of 1, axis of 2, axis of 3, something like that. So this is another way of creating those things. I hope that this is clear now. Now you can also create multiple figure with multiple axes. Like similar concept will be there. So you will be able to easily understand this code. Now we have the subplots 2. There will be only 2 rows and 1 column again. So here I call that axis 1 and axis 2. So how many of you understand this line of code? Tell me how many of you understand this line of code? Nice. So this line, I'm just reiterating this line. If I call plt.subplot of 2, so it will give, this is ax1 will have the axis of the first plot, ax2 has the axis of second plot, and this figure 1 is the canvas on which we want to plot. Then we can write this ax1.plot. So initially what we are doing, if you saw that, we're just creating a figure. If you see it here, we're creating a basically selecting the subplot by using the plt subplot function. But instead you can just write and you can name them. These two things are equivalent if I say. So but I'm naming them as ax1 and ax2. Now I don't need to call that subplot function because I called that here. I stored the values in ax1 and ax2. So now I can easily call ax1.plot and ax2.plot, and then we have figure 2 as well here. So similar thing if you see. So both of these things produce the same code, let's suppose. Like for example, figure 1 has 2 plots in there and figure 2 has only one plot. But the change that we made here is, here we were selecting the things by using the subplots, and in the next section here, in the next section, what we did is we were selecting the figures by just giving the names to them as ax1 and ax2, because I know that subplot, it basically returns me the values of these objects ax1 and ax2, so I can just collect them in somewhere. So is this clear? So there are two syntax of writing, you can achieve the same task. Then you can again see this multiple subplots in a figure with multiple axes, like for example in here. So what you created is, like, you have a plot and you created two sine figures, and I think it's easy to understand for you now. It's easy to understand because we understood the first code cell really well, so it's easy for you to understand this much. Is this clear? I hope this much is clear. So now we'll move on to next section. Let's maybe take a 2-minute break so that I also can catch breath and I can just drink some water. Then we'll move on. Are you understanding all the things? How many of you at least have understood 90% of the things? Okay. Zahid, if Hamul Noor, I think it's Arwa, if I am correct. Is it you, Arwa? Okay. Okay. Now we'll go on the different plots. Now you know that how to plot these things. Now I'd like to go on the different plot types, which I wanted to tell you that there are different types of plots. Like there is a line plot, there are scatter plots. There are at least, I'll say, more than 50-60 types of plots, but I won't go all of them. I'll just highlight few of them which you will be using heavily. So for that, we'll first start with the function which we have been heavily using. That's a plot function. Okay, we have something called as line plots. Okay, by line plots I mean if you plot something, it will be a line like this or it will be something like this. So these are called line plots. Okay, whatever you see in the cricket match, if there's a score and overs, you see a line plot there. Okay, so if you, for example, draw a graph and you draw a line in there, you see a line plot. It may be like this. If you have parabola, you will write something like this. This is the line graph, line plot. Is the concept of line plot clear? Okay, so how to create this line plot is, because we have been seeing it previously, we'll call this function plot. So basic usage I have written here. Plot takes an x argument, a y argument, then the format string. Format string basically how do you want to have the width, length and everything like that. So then we have these additional markers, line styles, colors, labels and legends that you can take. In order to just show you one example, so here this is x I am created. Okay, let me ask this question because this will be a sort of test for you. Zahid, so what will this line create? What is this concept called? I am doing something in x for x in range of 100. So what will it do? Anybody else who knows what is this concept called at least?
Sir, it will create a list of 1 to 100.
It will create a list of 100. This is called list comprehensions, if you remember this.
Sorry, sir, I was not able to unmute myself.
Okay, no problem. So again, this is the same thing. Here it will create squares of these numbers. It will create 1 square, 2 square, 3 square. Okay, this is my data. I'm just creating some data here. I'm just creating some data. Now I want to create a line plot. So I have been creating this line plot, I think, from previous half an hour. So you know that you just have to write plt dot plot, then give this x, then give y. R means red, and this label basically means I'll give this y. This label is the label, and plt dot x label means write this on x-axis, and y label basically means write this on y-axis, and put a title of plot of quadratic function. And plt dot legend basically means show this legend. So this is called a legend, and plt dot show this graph. Okay, so if I go to the coding window, I'll show you there. So where is it? I think this is the function. So just running this, You can easily see that plot of this quadratic function. Then we have this y-axis, we have this x-axis, everything, and this is a line plot. Again, I can create some other line plots for like this. So all the things that I have been doing so far, they were line plots mostly. So this is a sine function, this is a cosine function, this is a tangent function. So what I use some different markers. Here I use this red, green, dash function, and then I use some other things labeled as tan x. I hope this is clear. This line plot is clear. Is line plot clear? Okay. Now let's go to what is called as scatter plot. I think, now we have what's called as scatter plot. We'll write the scatter plot over here. Scatter plot. What this scatter plot is, you will have some points. Here what you were doing is, in these functions, you had only one, for example, you had 1 point over here, you had 1 point over here, you had some points. You did what's called as interpolation. Remember this word. You did something called as interpolation. You just basically connected these lines, these points. Okay? So I actually had the values for these points. If you see, I only had 100 values. For example, in here, I had 100 values. Okay? In the previous example as well, I only had how much value? I had 100 values. But you see that this is a continuous range of values. This is uncountably infinite values. This is infinite values. What it does is, it did what is called as interpolation. Interpolation is, we had some data points like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like this. So what it did is, it just connected these lines. And it created a line plot. Okay? Did you got to know how we'll create the line plot? Because we had some limited data, we only had 100 points, but what we did is, we did what is called as interpolation. Interpolation means just connecting these things and filling in the missing details. So we just filled in these things, and we created an infinite value line, and we called it line plot. But in scatter plot, you do not connect these lines now. So let's suppose we have some values. So in here, if you have values like this, so you have some values like this. So now you do not want to connect these lines, for example, like this, something like this. You don't want to connect these lines. You want to put the points as they are. You want to scatter them together. Okay? So this is what I mean by a scatter plot. So here, no interpolation is done, no connection is done. So whatever data we have, we keep it as it is. Is the concept of scatter plots clear and line plots clear? So in the scatter plot, what we do basically is, we do not do interpolation. Okay? So to create a scatter plot in matplotlib, we have a function called as scatter. It again do the same thing. It will take x value, y value, and then some other arguments as well. Okay? So it also takes C map. C map, it means a color map. I'll show you what color map means. I will just create a simple, let's suppose, a scatter plot. Okay. So here I'm creating a simple, firstly I'm generating some random numbers, and then I'm generating some again some random numbers for x, y. So for other arguments, size and colors, I'm also generating some 100 markers and these things. So if I run this, so what will happen? You saw that the points got scattered. Do you saw it? There we did not do any sort of interpolation. So what is the meaning of this C map? C map, if I remove it, so this basically is saying the more darker the points, this for example 0.2 value means like these points have on the x-axis, they have less value. For example, you see these points. So if you see these points, if you see point in here, this is a yellow color point, it's a very high value. This 0.8 says that it has very high value. These are called C maps. Okay, they are called color maps basically. If I remove this, the color map won't be visible. If I remove this, so alpha, you know, there is transparency. So if I run this, so I think C maps, or because I ran this and I had to restart whole other thing. So and you don't need to create a color bar as well. So you saw that here this color bar got, I basically don't know now. So why this the thing is, what is the meaning of this color? But if I want to know what's the meaning of different colors, so I can just plot this color bar. I'll just press Ctrl Z to get the code back. So color maps basically means I'm putting different colors. So here you can see the graph. So this graph basically, if you ask me what this graph represents, so here you can see that if there is a higher value, so you can see it has this higher value in here. For example, these points, if you see these 0.2 value, so this gives us a range of values. So these color graphs. So the only takeaway here is that it's a scatter plot. There is no interpolation happening. So you see these points are all over scattered. There is no interpolation or something like that. If you even remove these sizes, so you can also create a uniform size thing. But I have given different sizes and colors for different things. So you can remove these size and colors. Still, the scatter plot will happen. And these are some additional arguments that we can use with these scatter plots. Why are these scatter plots important? These scatter plots, we'll see why to use which plot. I'll just give you one example. I think I gave you the example previously. So these scatter plots are really important when you want to find some relations between the things. You want to find some relationships. For example, you want to see how is age related to, let's suppose, cancer. So you will see a person was having age this, but he has very less probability of cancer, things like this. So you will have some points like this, and you will find some positive correlation. So greater the age, the higher chance of cancer are there. Okay, if you want to find some other relationships, that's why these scatter plots are used, and we'll be seeing why to use these plots. Okay, so is the concept of scatter plots clear? Nice. Then we have something called as bar graphs. Okay, so again, taking the example of cricket, you might have seen bar graphs like this. This was over 1, this is over 2, over 3, over 4, over 5, over 6, over 7, like this. And you saw that how many, these are overs, these are runs consumed. And you saw that these buildings, in the first over 10 runs were consumed. In the second over, some 2 runs were consumed. Let's suppose third over was Medin. 4 over, we had some 20 runs were consumed. Something like this. How many of you have seen graphs like this? This is called a bar graph. Okay, I'm giving the example of cricket because many of you people watch cricket. That's why you might have seen these graphs. This is called a bar graph. So we have a function in matplotlib called as bar. So by which you can create these bar graphs. Okay, again it has I have given a basic usage syntax how to create these. You can just go over the documentation and see what are all the arguments that it takes. So here I am having categories A, B, C, D and E. So you can see that categories A, B, C, D and E on the x-axis. So to correspond to each category I have some value 7, 3, 12, 5, 9. So for example, for this value A I have 7. So you can see that it is 7. For this B I have value 3. You can see it is 3 over here. It can be even overs and runs as well. So the function I am calling here is bar. So I am giving categories, I am giving values. Width basically means how much wide this is. So width of each bar. So if the bar, this is the width in the bar. Then align, basically center means the alignment can be in the center, can be left, right. You can set the alignment. For example, if you write center, it comes on the center of this. If you write right, it will start basically from right. And this is the alignment. And then color, you have written as sky blue, and sky blue will happen. So now we have X label as categories, Y label as values, and the title of the graph is bar graph example. So is this bar graph clear? So you have a function known as bar which you can use to create these bar graphs. Okay, there are other types of graphs. There are stem graphs as well. For example, the stem graph, you have there is a leaf and there's a leaf and there is a root in the stem graph. These are called leaf root graphs sometimes. So I think created a graph like this. So it basically just gives the values, and in order to give the details of the stem graph, I think I again need 15-20 minutes. I hope that I'll just skim through over these graphs now. I'll see if there is some other graph which is worth explaining. There are a lot of graphs, and if you go on matplotlib documentation, you can see there are, I'll say, 50 plus graphs. Easily 50 plus graphs, and I don't want to go each of these graphs. There are stack graphs where you put all these on the stack. So for example, if you are doing some work and you are, for example, if you are in your day, you have Monday, Tuesday, Wednesday, Thursday, Friday, and then your activities are work, eating, commute, study and relax, and you want to stack these things together. So if you see this graph, and here you see on the Monday how you are spending your 24 hours. You are giving a solid chunk to work, you are giving some chunk of to eating, then you are giving this red means commute and things like that. There are a lot of graphs, and each graph has function. Stack plot is there. You can see on the above we saw that there are some other graphs like fill between. Like in my personal experience, I haven't used fill between. I haven't used the stack plots. I haven't used these stem plots. That's why I'm not even explaining them. But I am just telling you that these things exist. But in my personal experience, I have not used them. I have mainly used scatter plots. I have mainly used this line plots. I have used histograms. I have used these bar graphs. And sometimes I have used 3D graphs as well. So because there are more than 50 plus graphs I have not used, but these are the heavily used things. So that's why I'm just mentioning these things. Okay. And then we have something, this is called a step graph as well. This is a step graph. Yeah, sometimes this is called states. There's a function states. This is the histogram. This is basically used for distributions. How many of you, like, I think I'll cover this in probability as well. What are histograms? For example, if you have a lot of data and you want to create a histogram out of that, we'll see this. And I think pie chart. Many of you also know pie charts. So if you have different categories of things, so for example, category A has 25%, category B has some 35%. You can create a pie chart out of this, and there is a function plt.py. So I hope that you at least know how to create all of these graphs. If you have a graph, you just have to name. I think majority of the portion we covered. What is the meaning of legend, title, and things like that. The last topic I would like to cover is these are 3D graphs. Okay, there is a function called as, for example, what is it? It's a scatter plot, but it now takes 3 axes. These are again 3D graphs, something like this. There are contour graphs as well. So like in nutshell, I'll say there are a lot of graphs. So we have discussed, let's suppose, bar graphs. We have discussed scatter plots. We have discussed line plots. I think these 4 are more than enough for your assignments and for the work that you'll be doing. And if you have to plot some 3D graphs, I know that you will go to the documentation and read how to call these graphs. And I'll also share these notes. So another point is I learned about so many graphs. Okay, it'll again take me just 5 more minutes. I'll finish this pandas. Then on the next session we'll be starting with some new library. So I have to basically use all of these graphs. So I'll just give you an example. If you want to use a line plot, if there is continuous data, the data has a lot of types. Sometimes there is a continuous data. Let's suppose what is continuous. Time is continuous. Time data is continuous. And in the stock markets, because each second the prediction of the stocks or the stock price gets changed. For the continuous data, we mostly use these line plots. Okay, now we are here. What I'm discussing is which plot is used in which scenario of the data. In this continuous data, for example, stock data we have, time series data we have, or something. Some problem happened with this. So okay, what I'm saying is like the continuous data will use this line plot. Okay. Then the second diagram, if you want to see why are we using this bar plots, so they are used when we have this categorical data. So data can be continuous, data can be categorical. So in the categorical data, mostly we'll be using these bar graphs. Okay. Then if we have these histograms, so they are used in distributions, and we'll read about a lot of distribution. Like there is something called as Gaussian distribution. There is something called as let's suppose Poisson distribution is there. Random uniform distribution. There are a lot of distributions. For the distribution data, when we'll be going to probability, we'll be learning about these distributions. In that, we'll be learning about this, like why to use these histograms there. If we have these scatter plots, I told you why to use scatter plots. If we want to find some relationship. So if you want to find some relationship, for example, let's suppose between age and between cancer prediction, cancer probability, so you can use this. And for the hierarchical data, you can use these pie charts. Is this clear? Is at least the concept of how to create the graphs clear? So how many of you at least understood the things? Like we'll be now able to create these graphs. If given some data, we'll be able to analyze these things. Okay. So I skimmed over many types of graphs because there are more than 50 plus types of graphs. I don't want to go through every detail. You can create images, animations through the matplotlib. I just wanted to give you what is called like a sort of breeze, so that you know what is coming next if you are using it for the projects, if you are looking for analysis of the data, how to create these graphs. Okay. And in the next session, either I'll think if I have to cover Seaborn, the last library I'll be covering, or I will be jumping into matrix theory, probability, like basically mathematics. Okay, we'll be not just reading the theory of mathematics, we'll be again coding this mathematics. Now you have the background of NumPy, now you have the background of pandas, you have the background of matplotlib, and I'll think if Seaborn is required, because Seaborn sort of we can again create these visualizations using Seaborn as well. So I'll take a call on that. If not, otherwise we'll be starting with mathematics. We'll be discussing matrix theory, probability, stats. So these are the topics we'll be covering. I think we'll be covering probability, statistics, and then matrix. That's called linear algebra. Let's call it linear algebra. And then optimizations. These are the things that I'll be covering. I think I'll take one session for each of these so that your foundations are solid. Then we can move into the machine learning and coding of these stuff. So tell me, how many of you feel confident at least like you understood NumPys, Pandas and Matplotlib? If given some data, you'll be able to analyze it. Okay, so here I'll stop the recording. So if you have any questions, you can ask me some